Assalamu alaikum wa rahmatullahi wa barakatuh. How are you everyone? I'm Jana Ahmed Salk, and today we're going to discuss about vectors, adding vectors, subtracting vectors, and how to use particular theorem, and also displacement, distance, speed, velocity, and acceleration. So I think we're going to make a revision, okay, for all of this together. So first of all, vectors, displacement, velocity, and acceleration. Do you know what are the things that uh, relate all of them together? Of course it will be vector quantity, right? Because all of them are having vector quantities. But for displacement, I mean for distance and speed, both of them are related by what? By scalar quantity. So already we know that scalar and vector are different from each other, right? Because scalar is what? It's just for magnitude, but for vectors are for both of them, which is magnitude and direction, right? So to write the difference between scalar and vector, scalar and vector, that here it's only magnitude and here it's both magnitude and direction, right? And here always by positive sign, but here it can be both also, negative or positive sign. All right, so that means under scalar we can say that we have what? Distance, and we have also speed. But under vector we have what? Displacement and velocity with also acceleration. But here right now we're just two versus two. Okay, so that was about scalar and vector. Right now, what are vectors adding or subtracting of vectors? We know that vectors was what? Magnitude and direction. That means it can be south, north, east, and west, right? So that means it can be looking like this one. Here what we have is north, here south, here west, and here east. Here always positive, 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 and here negative, negative. Okay? Positive, positive, negative, negative. So for vectors, like for example of vectors are 20 north, or wait, before 20 we can say 20 Newton, or 20 meter north. We can say that it's an example of vector, right? But what if say addition and subtraction vectors? Like for example, if we have a 2 meter, okay, 2 meter are going this side, that means east, right? And another side which is going this side, wait, here to be the inverse thing, here to be positive and here to be positive, here positive and here negative. Okay, so here 2 meters and we have here what? 1 meter. Okay, 1 meter west. So what we are going to do here, we are going to subtract them, because 2 meter east minus 1 meter west is equal to what? 1 meter east. Why I say east? Because the large number are what? Are in the east. So it will be 1 meter east. That means it's already vectors having what? Magnitude and direction. Okay, but what if we say 20 meters east, okay, and 60 meter west. What we're going to do here is 20 meter east, here to be of course plus minus 60 meter west. That means it will be 20 meter east minus 60 meter west, which is equal to negative 40 meter west, or we can just say 40 meter west. Why? Because the large numbers are what are on the west, so that's why we did that. Okay, so right now for north and south here, we already solved for west and east, but what about north and south? Here to be what? North, let's say it's 50 meter north and 20 meter south, right? So here what we're going to do is just 50 meter north to be plus minus 20 meter south. So here to be what? 50 meter north minus 20 meter south, meaning that it will be 30 meter north. Okay, that was for subtracting of what of vectors. But what if adding of vectors being the same side? Like for example, here what we have 20 meter north. Okay, and the same thing here. We have 10 meter north. So this time it will be 20 meter north plus 10 meter north, which is equal to 30 meter north. Right? So it will be the same with east and west. Okay? So in the same direction, it will be always adding together. But in different directions, it will be subtracting. But we will put the direction depend on the large numbers or in the large magnitude. Okay, so that was for what? For vectors here. But what about finding resultant on particular term? Like for example, here what we have, someone who runs west, someone who runs east, alright? For 20 meters east. And then he changed his direction and ran 30 meter, what we have here east, and here to be south. Okay, so what will be his resultant? That means to be looking at this one. Okay, and then what we have is just the angle here, and the hypotenuse to be the side, which is the resultant. So right now what we have is 20 meter east and 30 meters south. So by using the particular term, which is c squared is equal to a squared plus b squared, where c squared is equal to a squared, what do we have here? Let's say a here and b here. So it will be 20 squared plus 30 squared. Then it will be c squared, which is equal to 20 squared. That means it will be 400. Why? Because 20, 400 plus 30 squared, that means 900. C squared, which is equal to 400 plus 900, it will be 1300. 000. Okay, so when you will find on the scientific calculator, you will find the perfect and perfect square of this one. Then it will be meter. Which one was the bigger? The biggest one? Or like both of them together, it will be southeast. Together, the direction. So that means we find the magnitude with the direction. Okay, so that was for what? For resultant. But what about for angle? How could we find for theta here? It will be tan, because to be opposite over adjacent. This one is adjacent and this one for opposite. And here we already have the hypotenuse, right? So that means tan is equal to opposite over adjacent. That means theta, first of all, what we have 20 opposite over adjacent, that means it will be 30 over 20. Cut, that means 3 over 2. Okay, 3 over 2 on the calculator. Okay, by using the calculator right now, first of all, what we was having here, c, which is equal to radical 1300, right? So that means it will be 10 radical 13 10 radical 13, or by this one to be 36.1. Okay, so 6.1 meters south-east. Okay, but here for theta, already what we have is 3 over 2. That means it will be theta of, to be theta, which is equal to tan negative 1 times 1.5. So for theta here, what would be here? Shift tan, then put 1.5. Then you will get at the end 56.3. Yes, 56.3 at the end. 56.3 degree. That means you find the degree, you find the angle, and you find also the magnitude with the direction. So this is kind of question also you can solve it, okay? So by using also for displacement and distance, that was only just for vectors. Also you can use it for displacement. Like for example, here if we have displacement, first of all, know what is displacement and distance. So displacement here right now, it's by what? By magnitude and direction, both of them. Displacement, it's by both magnitude and direction. But for distance, it's just magnitude. Okay? So right now here, if we have an example how to calculate the displacement and the distance, we know that the formula for displacement is what? It's like for example the change of displacement is equal to d2 is equal to d2 minus d1. d2 minus d1. This is a change of displacement. But for distance, it's just adding the two distance together. Okay, so right now here, what we have is a number line, or we can say the place or the distance that's how run. Right now what we have here 0, 1, 2, 3, 4, 5, 6, 7. Here negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, so our runner start from negative 3 until he reach 4. Okay, and starting from 6 and stopped until negative 4 here. Okay, so first of all here right now, maybe this is another, like first let's solve for the first one. First one, what do we have here? Negative 4 and 4, right? So the distance here is just calculating the both distance together. Like for example here, 4 plus 4, what do we have? Is just 8, right? 4 plus 4, 8. And then 6 plus 4, what it will be? 10. So that means the distance, okay, just the distance is equal to 10 plus 8, that means it will be 18 meter. Okay? 18 meter. But for displacement, it will be using the final displacement minus the initial displacement, or we can say d2 minus d1. So where is d2 and where is d1? So the point that started at the beginning, it is d1. That means negative 3. Wait, here it will be 4. Oh, that means here to be, let's say that it's negative 4. Starting from negative 4. Okay, so here right now what we have starting from negative 4 already, which is d1. And then d2 where you stopped. d2 which is negative 4 also. That means it will be displaced, is the change of displacement is equal to d2 where it is negative 4 minus, what do we have here also? Minus, because it's already minus in the formula. Minus what we have? Negative 4 also, because we start from d1 also here, negative 4. So it will be negative 4 plus 4, which is equal to at the end 0. So the change of displacement, it will be 0. But what will be if it was like just 1? This for 2. But what if it was for just one distance? Like for example, we have what? Here 0, 1, 2, 3, 4. Here negative 1, negative 2, negative 3, and negative 4. Right? So starting from negative 2 and then stopped until 3. Okay, so here the distance is what? What will be the distance? Just 2 plus 3. Just it will be. So the distance is equal to 2, 2 plus 3. That means 5. The distance is to be 5. Why? Because distance is always in positive. In positive, not in negative. Because it's a scalar quantity. But for displacement, it is a vector quantity, so it can be by positive or negative, either by positive or negative. Okay, so that means the distance here to be what? 5. For displacement, the change of displacement is equal to what? Here what we have d1, and then here what we have is d2. So starting from d2, which is 3, minus what do we have here? Minus also 2. That means the change of displacement is equal to 3 plus 2, which is equal to 5. So this is the change of displacement. Alright, so that was about distance and displacement. But what about velocity and speed? Velocity and speed are the same, but are having just they are the same in SI unit, but having different formula. So here what we have is velocity, right? Velocity, which can be also written by V, which is equal to V is equal to what? The change of displacement over time. Just the change of displacement over time, which then to be meter per second. But for speed, it will be just S, which is equal to D, which is distance over time, which is equal to also meter per second. The same unit, but just different here. The change of displacement, and here are just distance. Okay? So right now here, if we have like distance and we don't have time, but we have velocity also, so how could we find time or like all of this? By using the triangle, okay? By using the formula of triangle, we will get easily every unit or every quantity here. That means here what we have is just a displacement and V and T. That means if we want to find the displacement of the change of displacement, that means change of displacement is what? Velocity times time. Change of displacement is equal to velocity times time. Okay, that means to be change of displacement is equal to Vt just. And for velocity, it will be the same as change of displacement over time. And then time, it will be change of displacement over velocity. Change of displacement over velocity. How could we be sure about this one? By using crisscross on this formula. Like meaning, V is equal to change of displacement over T, here over 1. Then crisscross, that means it will be change of displacement is equal to times T times V, that means it will be Vt. So that means it's correct. But for the second one, which is time, how could we find for time? Is by using this formula again, AD, which is equal to Vt, then multiply both sides by V to find T, then T is equal to change of displacement over V. That means it's correct. And the same thing with speed. It will be. Here it was for just velocity, but for speed, to be the same. What we have here is D, S, and T, meaning that D is equal to S and T times S times T, and T is equal to D over S, right? And already we have S is equal to D over T. So that means we find the whole formulas that's related to speed. If we find that, and if we don't have that, that means we are going to use all of this together. Okay, an example of meter per second. That means for velocity, and example for as well. A line that's run for actually, we let's say that 5 meter. Okay, starting from 5 meter and stopped until 12 meters. Okay, under 5 seconds. what will be its velocity. So velocity meaning change of displacement over time, meaning that it will be velocity is equal to d2 minus d1 over t. Right now, we're here d1 and d2. Final displacement, it will be d here, it will be 12, that means d2, and then it will be d1. So v is equal to d2, which is 12, minus 5 over time, which is 5 seconds. That means 12 minus 5 here to be what? It will be 7 over 5. That means velocity is equal to 7 over 5 meter per second. Okay, and the same thing with speed, but here instead of having a change of displacement, we just have the distance. Like for example, distance of what? Of 20 meters. Okay, 20 meters, and under what? Under 2 seconds. That means it will be speed is equal to 20 meter over 2 seconds. Okay, then here to be 10. That means speed is equal to 10 meter per second. Okay, so that was for what? For velocity and speed. But returning to displacement, we can also find displacement as a resultant form. Like for example, by using vectors, we can find displacement and distance by using just vectors. Like for example, here we have what? A runner that's run to the east, or we can say down because we need to make north. Okay, so run to the east, let's say 6 meters east, and to the north, let's say 9 meters, or make it as small, much small, that means 3 and 4. So here to be what? 3 and here 4. 3 and 4 meters north. So what will be the resultant? Okay, or we can say the displacement, the change of displacement. The distance, first of all, it will be just the sum of these two. The distance, it will be just 4 plus 3, which is equal to 7 meters. Just. Okay, but for displacement, it will be changed because it will be whether either the east, north, or having both of them because it's having direction. Okay, so here it will be the same thing using c squared, which is equal to a squared plus b squared. Then c squared is equal to a squared. What we have here? Let's say it's a here and b here. So 3 squared plus 4 squared. C squared, which is equal to what we have is 9 plus 16. C squared is equal to 25. Okay, then c is equal to 5. Okay, so c is equal to 5 what? C is equal to 5 meters northeast. Oh my god. So that's what it was. For a little, I think my heart was just stopped. But anyway, C is equal to what? 5 meter northeast. Okay, 5 meter northeast. And then what we have is just finding the angle right now. Or like no need, well, because we already find the change of displacement and we find distance. But if you want to find angle, it will be the same thing. So that was for what? For displacement, velocity, and also distance and speed, and also vectors. But what about the acceleration? Acceleration is actually, we can say that velocity over time, because it's meter per second squared. And also by graphing, we are going to graph acceleration together. Okay, so here what we have acceleration, which is equal to velocity over time. Why? Because it's meter per second squared. Why? Because velocity is already meter per second and time is second. So when it is A is equal to meter per second over second, that means it will be meter per second per 1. That means it will be meter per second times 1 per second, which is meter per second squared. This is how could we find s squared. Okay, so that was for the unit of acceleration. So right now here, if we have the acceleration, it's how speed or how speed and distance uh, during a time can this runner speed or that runner can run. Like for example, we have a velocity of 20 meter per second and we have 5 seconds. So what it will be, a is equal to 20 meter per second over 5 seconds, right? That means a is equal to here by 1 and here by 4, so it will be 4 meter per second squared. Alright, so that was for what? For acceleration, how to find acceleration. But also we can find for t and v at the same time by using what, the triangle that is here a, here v, and here t. That means it will be, we can find for velocity, which is velocity is equal to a times t, or for t when t is equal to v over a, and the same as for v, for a is equal to v over t. Okay, so this if we want to find. All right, for right now here, we say that we have get what, 4 meter per second squared, right? 4 meter per second squared, and we have already the time, which was 20 meter per second, and here what we have, it was 5 seconds, right? So we can graph as what? Here what we have is 0, then 2, then 4, then 6, then 8. Here it will be 2, 4, 6, and 8. Okay, so what we was having here, it was 5 seconds, and okay. So right now, in place of what, we have 4 meter per second squared. So until reaching 4 meter per second squared, that means it's just by 5 seconds more, it's adding. That means for 4 meter per second plus 5, it will be what, 4 plus 5, it will be 9. So in place of 9, then 9 plus 5, again, it will be what? It will be 14. Then again, plus, it will be just increasing from what? From 20 meters per second. That means here 20, starting from 20, that means it will be accelerating. It should be looking like this one. Okay? So, like, let's take another example that's more easier than this one. Like, for example, if we start from here, it's meters per second, just, which is velocity, and here, which is time, second. Okay, then what we have here is 2, here 1, 0, here 3, 4, here 5, 6, here 7, and here is 8. Same thing here, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, right now here what we have is velocity, and here we have time. So in acceleration, what we are going to do is, we are, first of all, we have what? Here 2 as velocity, and also here what we have is another 2 or 1. Let's take by 1. So it will be just 1, or we can say over 2. It will be 2. Okay, meter per second, and here second. That means it will be 1. Then another one, what we have here? 3 over 3, that means 1. That means it's just moving 1 second. So here 1, 1. Here 1, I mean here 1, 3 to 3, and here 2, 2, and here 4 to 4, 5 to 5. Okay, because they are just moving what? 1 second each. 1 second each. 1 second each. Here 1 second. Here 1 second. Here 1 second. 1 second. And also here 1 second. Okay? So after that also, what will happen if we have like a question that says for the first distance, starting of 5, okay, start from 5 meters, just to, let's say it's 10 meters, under Okay, under what? 5 seconds. So what it will be is acceleration. So first of all, what we have for acceleration is equal to what? Velocity over time, right? So right now what we have here is just change of displacement. That means we should find for velocity. Velocity is equal to what? Change of displacement over time, right? Change of displacement over time. That means it will be v, which is equal to 5 meter, 10 meter minus 5 meter over t. 10 meter minus 5 meter over t. That means v is equal to 5 over 5, which is equal to 1. That means we already have 1 here, so acceleration is equal to 1 meter per second over 5 seconds. So it will be 1 over 5, or we can say 0.5 meter per second square. That means each second that's going here to be just 0.5 second, then 0.5 second, then 0.5 second, and continue. Okay, so that was for what? For acceleration. So I hope that you understand the meaning of vector and scalar quantities and how could we identify between them, because scalar is just for magnitude and vector is just for magnitude and direction, both of them. Scalar is always positive, vector is just for negative and positive, both of them. So also we identify the forms of displacement, distance, velocity, speed, and also acceleration, and also how could we add vectors, subtracting vectors, and also by using Pythagoras theorem we can find resultant and also displacement. Okay, so that was everything for today. I hope that you understand today's topic, and inshallah next time we're going to do more topics that's related to physics. Have a nice time and bye, goodbye.